Okay, dimensional analysis is the type of question that used to come up before. The first one's been done for you, area. If you notice here, 4D plus 3R plus 5H. Remember, the numbers don't count. They don't mean anything in this topic. The numbers do not mean anything at all, right? So you just got D plus R plus H. These are all lengths that we're adding. If we add lengths together, it just gives you another length. Okay? Now, careful down here. Again, the numbers don't count. Here you've got RH. Now that's an area, of course. Here you've got h squared r, so that would be 3 dimensions. That's a volume. Now that doesn't make any sense at all. When you add an area and volume, it doesn't make any sense. So you literally just follow what it says there and just write none. Here you've got, that's an area and that's an area. So remember, with like Bodmas, you do the bracket first. You've got an area here and an area. Well, that just gives you an even bigger area. So that just like, I'll write it down here, that just becomes like L squared in that bracket, so to speak, because you've got an area and area. So it's like L squared. On the outside then you've got an L as well for the length. So when you multiply, that would be L cubed, so that gives you volume. Okay? And the last one, RH, R squared, RD, that's obviously area. Okay, ignore the numbers. Job done. Last question, density. It says a cylinder has uniform circular cross section of radius 4.7 and height 23.5. Calculate the volume of the cylinder. Okay, if it helps, you can sketch this. Okay, now the height is 23.5. You don't have to sketch it. The radius there is 4.7. Okay, not a particularly great sketch, but you've got the dimensions there. The volume, pi r squared h, 3.14 times 4.7 squared times the height, which is 23.5. So you get 1630.02, okay, centimeter cubed. Part B, it says a rod has a uniform cross section of 42.8 centimeters squared along its length of 24.9 centimeters. It has a mass of 9.9 kilograms. Calculate the density in which the rod is made. Now remember, for density you need the mass and the volume. Now they don't give you the volume, but they do say it. They actually tell you the uniform cross section area. Okay, it's quite wordy, but they tell you the area of the uniform cross section. You see centimeters squared, so it is area, and then it's got its length. So the volume, if you just go back to the basic formula we learned before, is area of cross section. It's on page 2 as well, on every exam paper, but it's as simple as an area of cross section times length. So it'll be 45.8 times the length, which is 24.9. Okay. That comes to that number. Press the SD button, 1140.42. Okay, centimeter cubed. Right. Now remember, then you've got your volume, you've got your mass. Be careful with the mass, please, because it's 9.9 kilograms. We need to change it into grams. Okay, so that you need to times that by 1,000. So you get 9,900 grams. The density formula, okay, it's up to you if you remember the triangle. Okay, so if you want density, it's mass divided by volume. Cover density, yeah, that's what you want, so it's m over v. Of course, I told you in class that another clue is they actually tell you the formula here in certain questions, some questions. Mass for grams, centimeter cubed over volume. So the mass on the top, 9,900 divided by the volume. So on my calculator, 9,900 divided by the answer from before, 8.68 grams per centimeter cubed. Okay, well done. So well done if you've done all of them. Okay, if you need more, then obviously go back to the work we did in class, finish off any work, but also redo perhaps some of the more challenging questions, such as the volume questions. Okay, and some of the arcs questions as well.